Okay, the first two questions, chapter 6, test, have these instructions. Find the component form of the indicated vector. And in each case, they will give you a u and a v. They're different for number 1 as they are for number 2, but they'll give you a u and a v and ask you to do something with them, some arithmetic calculation. People miss this because they fail to pay attention to the signs on the numbers. You got to pay attention. So if I were to give you, for example, that u is equal to negative 4, 3, and v is equal to 7, 2. And they wanted you to do this, find v minus u, for example. Then you would do this. This is what you would do. You could probably do it in your head if you're careful, but you have to take v. You got to start here. You got to take 7 minus negative 4. And you got to take 2 minus 3 to get the result. Yeah? Okay with that? Number 2 is like unto it, gives you a u, give you a different u, 5, negative 7, and a v, 4, 4. And they might ask you to do something like this to find 5u plus 8v. Like that. And to do that, you need to, if I were you, because this is a test, I would slow it down, think about it better. I would take 5 times u. 5u is 25, negative 35. 8v is 32, 32. So these numbers get pretty big. And then just add them together. 25 and 32 is 57. And negative 35 and 32 is negative 3. That's what you put in the blank, because they want the component form of each. Anytime along the way you want me to slow down and ask a question, go ahead and do that. I'm going to keep plowing ahead so that when it does get tougher, we've got time. So that's the first 2. Most people, but if they do miss it, it's because of a sign error almost exclusively. Be careful with your signs. Number 3 says, find the unit vector in the direction of the given vector. Write your answer in the indicated form. They give you a u vector, say it says u equals, and they give it to you in component form. Something like 4, 9. Give you a vector that says, find the unit vector in the direction of u and write your answer as a linear combination of the standard unit vectors I and j. So we're going to find the unit vector, and then we're going to make sure we write it in the correct form. The unit vector requires you to know the length of u, which is 16 plus 81, which is 97. Did you catch all that? Pythagorean theorem. You need the length of u, because what you're going to do is the unit vector, get my pen right. Unit u is going to be the x component divided by, I'm sorry, that's not the 97, it's the square root of 97. It's my fault. Sorry. Forgot the square root. Okay. Over the square root of 97, comma 9 over the square root of 97. That is the unit vector in the direction of 4, 9. If you report it this way, you'll miss one for not following instructions. The answer is 4 over the square root of 97i plus 9 over the square root of 97j. Do not mix the hats with the plus sign, with commas. There's no comma in here. This is a sum of 2 vectors to write it in that form. So this is what goes in the blank. We okay with the unit vector? Yeah, okay, next. Number 4 gives you a picture of a vector on an XY grid, and it says, find the component form of vector v. Something like this. Something like maybe this, put a 65 on it, and an angle right here that is 35. You are to write the component form of that vector.
And this is the one that they give the graph, right?
Yeah, it looks something like this. And they give you an angle and they give you the length. Okay? You do not write this. To start, what do you write?
Cosine
215. Good. You write that vector, or that angle, comma, 65, sine of the same thing. But this is not how they want the answer, because it does not say leave it in cis form. It's not even cis form. It doesn't even say that. You need to actually calculate these. Make sure you're in degree mode when you do it. They want the actual numbers. And people always say, well, what do we round to? And the answer is something reasonable. I don't care. If you're close, I'll give it to you. Usually the nearest hundredth is a good default if you don't know where else to go. So make sure you're in degree mode. And do 65 cosine 215, and I get 58.91. Sine. No, that's not what I got. Yeah, I know, that's not correct. I typed something badly. Hang on, I gotta try it again. 65, I left the 1 out. I got 25 degrees instead. Hang on, 65 cosine 215. Negative 53.24. That sounds better because it's in the third quadrant. Negative 53. Did you get that too?
Yeah. Yes.
Now that I typed it right. Sine. And I get negative 37.28. This is what I expect to see in the blank. Something like that.
So you don't do anything with degree, the 35?
Yeah, you have to.
Yeah, like you don't.
No, you don't use the 35. You reconcile that angle to be 215 in this case. Got to start from over here. Anytime you're doing any sort of math or calculations, you're going to want to start here and come this direction. When you first read a problem and they give it to you in navigation, you want to start here and wrap it around this way. And then when you write it down to calculate with it, you got to find the angle that comes in this direction.
Yeah.
Tricky. Number 5. Number 5 is a story problem of sorts. It's not a big deal though. It doesn't give you any pictures. It gives you a description and you got to draw your own. This is the instructions for number 5. It says, find the magnitude and direction angle for the following vector. Give the direction angle as an angle between 0 and 360, rounded to the nearest tenth. So pay attention to the instructions. And they give you a vector like this. Number 5. Something like 5, negative 8. So that's the vector, and these are the instructions. Find the magnitude and direction angle for the following vector. Give the direction angle as an angle between 0 and 360. Means it's got to be in degrees, and you've got to do it in one. You've got to find the terminal side in one wrap around, one go around of the circle. So the magnitude of this vector is going to be the square root of 25 plus 64. You understand where that's coming from? And that is what? 89? Is that right?
Yeah.
Square root of 89. So you would write that. You would write mag equals square root of 89 in your answer blank. And direction. How do we find direction? Here's how I find it, and I'm only going to demonstrate the way I would find it. I would plot that as an endpoint. I go out 5 and down 8. Me personally, this is what I do. I put a 5 and an 8 here, and I find this angle. And then I add it to 270. No, I subtract it from 360. Sorry. That's what I would do. But I find the angle in here, and I know you're saying, but that 8's negative. Yeah, you're right. It is, but not for a triangle where I'm trying to find this small angle. I want to use capitals. I want to use positive things. And so and this is how I do it. I say the tangent of alpha is equal to 8 over 5. So alpha is equal to the inverse tangent of 8/5. And then I go to my directions and I realize, oh, I'm supposed to be in degrees, so we're still in degrees. We use the inverse tangent of 8/5. Inverse tangent. Is that a tangent? Yep. 8/5. And I get 57.99, so virtually 58 degrees. So then I take that from 360. Because that's how far short I am of making it all the way around. So it'd be 302. And if you want to round it to the nearest hundredth, it would be 0.01, but just 302 would be fine.
Wait, what did you do after you got the 58?
This is 58, so I subtracted it from 360 to get that. Right?
Yeah.
You're 58 degrees short of making it all the way around, which means you're 302 degrees into this by the time you arrive there. That's how I do it, because reconciling the angles is better than trying to figure out what the negative sign did to me. Because you have to remember that if you're going to use an inverse tangent and you got positives and negatives, which quadrant it's defined in and which quadrant you can find it in. Instead, I don't even think about that. I just find this angle using a triangle that doesn't have to be oriented this way. I could just as easily have used this triangle and found this. You know what I mean? Doesn't matter where it is, as long as the sides are, you can find the angle in any right triangle if you want, and it doesn't matter where it's oriented. This matters. If you're going to use the signs, the -8 and the +5, that matters. And now you're going to have to think about where tangent's defined and where it's negative in that definition and how you reconcile it, all that kind of stuff. It's not exciting. Most people screw it up. Find the positive angle and then reconcile it to the unit circle where it's located. That's right. Okay. 6 and 7, the instructions are extremely simple. The problems are rather hard. Well, it says solve the problem. Number 6 says solve the problem. And then here's what it has. It says something like this. One pulls a barge directly west with a force of 80 newtons. Here's the barge. Here's the first rope. Here's how long it is. Not the length of the rope, how hard it's being pulled. It's 80 newtons, directly west. And another rope pulls the barge directly south with a force of 110 newtons.
Will they always be exact northeast?
In this problem, they will all be, what do they say? How do you say that in orienteering? One of the 4 directions, cardinal directions. Okay, so this is what you get. This is what was said. This is what you draw, and then it says find the magnitude of the resultant force. All you have to do is find the magnitude of the resultant force, and here's how I think of it. You can either take this one and put its tail down here and tip out this way, or you can take this one and move it over here. I'm going to move this one over here because it's the same equivalent vector, where this is 110. And this is the resultant. Cardinal directions, finding the magnitude shouldn't be very hard because all the cardinal directions make a right angle. Pythagorean theorem, straight up. The magnitude of that resultant vector is the square root of whatever 80 squared plus 110 squared is, and I would prefer you don't leave it in radical form. I think it says rounded or something. No, it just says find the magnitude. I guess you could give me the correct root if you want it, but it better be simplified. Best bet, just calculate it. $136.01, yeah. They only want the magnitude. Number 7, that's where problems start to happen. Number 7. This is where people start to miss problems. Most of the time, they do pretty well up to here. Number 7, under the instructions, solve the problem. Here's what it says. An airplane flies on a compass heading of 270 degrees at 480 miles an hour. I would draw that if I were you. Compass heading of 270 degrees means you start where and wrap it how? Straight up and wrap it 270 degrees clockwise. So the airplane's going out this direction. Yeah? At 480 miles an hour. The wind, which is affecting the plane, is blowing from 52 degrees at 55 miles an hour. Where's 52 degrees? About right there, right? And the wind is blowing from that direction. So this is 52, that's the information you get. And the length of this, obviously not drawn to scale, but the length of it is 55 miles an hour. That's the length of the vector, but it's coming from an angle made bearing-wise of 52 degrees. So where's the 52 in this picture where we actually have the vector? It's right here, because if you remember, vertical angles are equal in geometry. These two angles are vertical. You see where it shows up over here on the vector? Okay. So now at this point, by the way, they want the magnitude and the direction of the resultant vector if the guy just allows himself to be blown off course by this little breeze. Excuse me. So we're looking for a vector, believe it or not. We're looking for a vector that stays mostly on course here, but it gets blown this direction a little bit. And believe it or not, it's going to be a little longer because there's a piece of this wind that's helping him. You know what I'm saying?
So we just created a vector in the middle.
Huh?
So we just did right there.
Yeah, the vector will be in between the two because he wants to go this way. The wind is pushing him this way a little bit and also helping him a little bit this way. So it's a little longer and it's off course in between the two. How do we find the things we need? Two ways. You can take this vector, bring it out here, and make a oblique triangle out of it and use the law of cosines to find the things you need. Could do it that way. Could also find the component form of this vector and this one and add them together. I'm only doing one way. Tell me what you'd like to see. All right. So what is the component form of this black vector here, the airplane vector?
480 cosine.
Let me ask you this. What is this point?
480.
That would be 480, right? Or negative.
Negative 480. We don't need to do the trig on it. We could, and it would give us the same thing, but we don't need to do the trig on this one because the component form of this vector is this point, but it's a point figured by just regular old xy. This is the x-axis, this is the y-axis. We have gone 480 out left on the x-axis. So this is the point, which is the same as the vector. 480, negative 4, negative 480 because it's left, 0. That one's not too bad. And the one on your test will be a quadrantal angle as well. So you should be able to find that vector without doing the trig on it. What is this vector? Now you can tell me stuff like things you wanted to, Katie.
What do we have to use the whole angle or just the triangle angle?
No, you have to use the angle made from here around to here. Remember, if you're going to calculate, make vectors, you have to put the angles and the degrees and everything in here this way.
You still have to do it this way though,
Like the normal way that we've been learning all year long.
normal way of direction.
The way you get these vectors on here is to go north and fall to the right,
And
which
that's
is
the only time
clockwise.
I have
But
to
once
do
you
that.
get here and you're writing things down, you got to make that angle come around this way.
Is that the only time you have to do that?
When you're trying to get a component form of a vector, yeah.
And then the rest is just normal?
What do you mean by normal?
Like trying to figure out the
Oh,
angle?
yeah. The only time you have to use bearings, which is to start here and go this way, is if they say, if it's a ship or an airplane and they tell you the angle, you have to go compass wise. Calculate, you have to give me the angle this direction. So what is the component form of this? Cosine of what? 218?
Yeah.
So you just go 270 minus 52.
Yes. 270 minus 52, because you need this angle coming around this way. comma, 55 sine of that same thing, right? In degree mode. And now we need to add the two together. So the resultant, component form of the resultant is going to be negative 480 plus whatever this is. And this exactly, because adding 0 to it does nothing. So that first component is negative 523.34, is that right? Which makes pretty good sense because this point right here is what we're looking for. That went out more than 480 because it's being blown somewhat this way by that wind. So that's how much farther we gain an extra about 43 miles an hour. Anyway, the other one's just going to be 55 sine 218 added to 0, which is negative 33.86. That also should make pretty good sense based on what's going on because this wind hasn't blown it off course very much. So that 33 degrees is pretty small. I mean, compared to that. I mean, not 33 degrees, but that's this component right here. If this is 523 out to here, then it's only 33 down to here. So it's not blown off course by much. Do you know what I mean? It's not degrees. That's an actual miles per hour thing. And it is in the third quadrant, which we expected. They're both negative, so that means we calculated right, probably. Still haven't answered the question.
Oh, what? Oh, not that.
No, this is not. This is just the component form of the result. It says, what is the true course and ground speed of the airplane? True course and ground speed. How do we find the, I'm going to go ground speed first. How do we find the ground speed now that we know the resultant vector? That right there. Because this is going to be a right triangle out to here, which is left negative 523.34 and down 33. So I want to know the length of that. That's Pythagorean theorem. 523. Well, actually, I'm just going to go grab that. Square plus that. Square root of it. Oh, this calculator is so completely and totally bent on order of operations. Can't have that negative in there. It won't square it.
Square both points.
Okay, I get 524.43. Is that right? So the magnitude or the speed of the airplane. 524.43. What? What's it measured in? Miles per hour. And the direction? The direction means I need to find this angle right here and then reconcile it with bearings. Yeah? Yeah. So this was the right triangle. This if I go this right triangle right here, this is the resultant vector with the right angle right there. To find that angle right, the inverse tangent, 33.86 over 523.34 without regard to sine because I'm in a triangle now. So we go inverse tangent of the short, which is 33.86 minus, no, over 523.34. And I get 3.7 degrees. Is that what you're getting?
Yeah.
Reconciled with the direction that comes around here, I'm going to take 270 minus that. 266.3 degrees. These are the things that you write in the blank. So you draw your picture according to bearings, you do the work according to measuring angles, whatever, we've always measured it. If you're going to make vectors. Okay. Number 8 says eliminate the parameter. We skipped the section on parametric equations entirely. So if you want to know how to do that and you've got the time, you want to look it up. I will tell you this, the two pieces of the parametric equation involve trig functions, sine and cosine, in some way or other. So go look that up, know how to do it, and get some bonus points. Number 9 says find the rectangular coordinates of a point with the given polar coordinates. So it's going to give you a point, polar coordinates. Remember, the first coordinate is r, second one is theta, and it's theta measured in the normal way, not a bearing. Okay, so it gives you a point. So number 9 just hands you a point, and it's something like -5 and 5/3. We'll say. They want the rectangular form. They want the XY coordinate at this point. So you're going to have to know how to plot it. This is how you show your work on this. And it's kind of strange with polar coordinates. If you'll remember, you spin the angle first, right? And then you backtrack because in this case, the radius is negative. If it were +5, you just put a point right there and then find that using a triangle. But as it is, we spun the angle, but it says the radius is -5, so we've got to come back here 5. This is the point that we really want. This is 5. This is 60 degrees. Yeah. So this is 5/2 negative, and this is -5√3/3. No. That. It's this, whatever the length of this is, times the square root of 3. Now try. That means that that point right there, which is the answer to the question, is -5/2 5√3/3. Now you may be thinking, is this angle over here going to be a one that we're used to? Yes, it is. It's not going to tell you what it is. It's one that you've studied. It's a normal. It's a familiar one, and so you should be able to answer your question with radicals if necessary. Everybody okay on that one? Okay. Moving on. You all right, Danny?
I think so.
All right. Guess what the next one is? Here's a rectangular coordinate. Find the polar.
Oh,
It's
it's J.
Yeah, wait, is that supposed to be a 2?
What?
In your answer?
Yeah, should be a 2.
Okay,
I keep
so-
getting hung up on 3s. I don't know why.
But isn't there like a different way you could do that one?
Sure. There's all kinds of ways you can do these things. If you got a way that'll get you the same answer, that's great. It does not say what form it has to be in. So if you want to, if you don't remember these or you don't want to put it in radical form, as long as you got a correct decimal, it's fine.
Okay, so you put it in your calculator.
If you know how, yes.
So on that one, to put it in your calculator, would it be 5 cosine? Pi thirds, and then 5 sine pi thirds.
2/3.
Okay.
Really, you guys haven't learned this well enough yet? It just, you guys make me nuts. Whatever. You can check it with your calculator. I don't care how you do it. Get the right answer. That's all I care. And if you're gonna get your right answer, or you want me to see your work, make sure you show me what you put in your calculator. Because if you just give me an answer and it's wrong, you miss it all. So you gotta be able to show me something. Okay? This would be a nice thing to show. Or at least show me what you wanted the calculator to calculate. Number 10 says determine two pairs of polar coordinates for the point where theta is between 0 and 360, and this is the rectangular point, something like this. This is number 10. If you're a rectangular point like 9, no, that's not a vector, it's just a point. 9, -3/3. That's the rectangular point, and you're supposed to find the two polar coordinate points. we're gonna go backwards. Which first thing you probably should do,
Graph it.
graph it, plot it, yeah. We're gonna go out 9 and down. 3, we're at 3, that's about 5 something, so it's not down 9, it's about like this. Okay, so there's the point, and we want the polar, 2 sets of polar coordinates for it. What do we need to write a polar coordinate? You need an R and a theta, and the theta has to be between 0 and 360, so you can't use this as theta. Has to be between 0 and 360. So we need this angle, and we need this length, and we have this information here. If you draw a triangle, we have 9 and 3 root 3. And I know it's negative, and I know you know it's negative, but I want to find this using the positives. The R is going to be the length of the hypotenuse. So say 9 squared plus parenthesis 3 square roots of 3. Close it. Oh, come on. I hate this pretty print. Can't ever do anything. Squared. Square root of the answer. Looks to me like 10.39. Is that what you're getting? Yeah, no?
Yes.
10.39, and you can express it that way, but these particular numbers have been designed to fit a certain type of triangle. What if you took 3 root 3 times root 3? Wouldn't that be 9? Doesn't that make this 30 degrees? Because if you take the short leg times root 3 and you get the long leg, which is what I just did there, then you got a 30-degree angle here. Which makes this 6 root 3. That hypotenuse, because whatever the short leg is, doubled is the hypotenuse in a 30, 60, 90. Now, 6 root 3, I suspect, is 10.39. So I am going to use 6 root 3.
Would it be wrong if we use the 10?
No, it'll be fine. I will tell you this, however, the very, very first problem on your final exam is not like this necessarily, but it uses that I just brought up. That is, short leg times root 3 is long leg, short leg doubled is hypotenuse. Or perhaps the facts in a 45, 45, 90. So eventually, and they do want it in simplest radical form, so eventually you're going to have to fall to this anyway to do the final exam. Very first problem on the exam has this situation. Okay, so anyway, I'm going to go with 6 root 3 because I recognize that 30, 60, 90. It also tells me what this angle is. It's 330. Yeah?
Yes.
Okay. You could also put it in radian, I suppose. Let me see if it's in radian. Yeah. No, it does. It clearly says that the angle needs to be between 0 and 360. So that means degrees. So this is one expression of that. The other one, since this has to remain 330, the other one's got to be, well, actually, since this has to remain between 0 and 360, I can't just say, okay, another name for that would be 6 root 3 negative 30. Can't do that and get it correct because the angle has to be between 0 and 360. So what they're forcing you to do by making that stipulation is coming out here and asking you to give the negative, which would be negative 6 root 3. But then what would be the angle? That one, 150. Did you catch that or not? Anybody have a question about that?
Where'd you get that 150 from?
Because if I follow this exactly backwards like this so that I have a negative radius for this point,
Oh, okay.
the angle that I opened up is exactly 180 degrees short of that.
Okay.
Did it give us the 30 degrees or did we?
No,
just
you have
do
to
it
figure that out.
percentage?
All they gave you is this. This is it.
Okay, so
You go out 9 and down 3 root 3 and plot a point. They want two names for that point, one with a positive radius and one with a negative radius. And we came up with the 30 degrees because these two things happen to fit a special right triangle that we know of. So we knew that that reference angle was 30. That'll happen to you on the test too, if you know how to reconcile it. If not, you get it. Do the decimals if you want.
So you only need one of those answers?
No, you need to both.
You need both. Okay.
Yeah, it says determine two pair
Two
of
pairs of
polar coordinates where theta is between 0 and 360 for this rectangular point, 9, negative 3 or 3. And I will tell you that the rectangular coordinates, this part that they give you, will belong to a special right triangle if you can identify it. So you can give your answer in radical form and degrees. You have to give this in degrees no matter what, but you can give this in decimal form if you want. It doesn't say it has to be in radical form, but this will fit a special right triangle. Okay? If you can recognize it. Okay. Number 11, to show you one like this is to give it away. Not the actual numbers, but to show you how to do this one. If you can remember when you see it, how to tackle it, it'll be pretty easy because I'm going to show it to you. The proper way to go about it. Number 11 says, find the equivalent equation in rectangular coordinates. So I give you an equation in polar form, and you've got to change the equation to rectangular form. It's something like this. R equals 7 over 3 sine theta minus 2 cosine theta. So it gives you an equation like this, and it says, find the rectangular equivalent of this. Means when you're done, you better have x's and y's, not r's and thetas. What do your instincts tell you?
Approximately.
Hallelujah, yes. And assume that's over 1, in which case you get 3r sine theta minus 2r cosine theta equals 7, yeah? Does that make a sense, distributing the r?
Yeah.
Okay, and then 3
Y.
y minus
2x.
2x equals 7. Done. You can solve for y if you want, but you don't have to. It's got the x's and y's in it. It's in standard form. It's not in slope-intercept form, but that's fine.
That's it.
So that one. If you know how to start, it falls out pretty well. I mean, if you know how to start, and you also recognize this as being something, x and y. Okay, the rest of the test is about cis form of a complex number. 6.6, in other words. If you haven't done section 6.6 yet, this won't make a lot of sense to you. You got to practice this stuff, folks. So, first one, number 12 says, express the complex number in trig form. The complex number is something like this. What do you suppose we got to do first? Plot it on a real imaginary grid. Remember, this is the real axis, this is the imaginary axis, and so we would go back 8 and up 8. And our goal is to find this angle and this length. I'll call it R for resultant, I guess. I don't know. It's not really a resultant, but kind of it is. And that length is going to be 64 plus 64 square rooted. Which I think is 8 root 2. So R is equal to 8 root 2. And because we went out and up the same amount, that means this angle is 135 degrees. Right? Or 3 by 4ths, whatever you want. Do you want the degrees? Let me see if it matters. How do you express it? It says, oh no. It just says to express it in trig form. It does not tell you how you have to measure the theta. So if you want 135, that's fine. So trig form would be 8 root 2 parentheses. That way you don't have to write it twice. 8 root 2 is going to be the R value, or the length of it for both of them. What do I write here?
Both sides. 135.
Done. That's your cis form. You could also write this if you like, if you're really bent on saving graphite. That's fine too. This is also fine. You like radiant mode? I do. That's what I would have done. I like radiant mode. So. Everybody good on number 12? What you got to do?
13. Is that 13? That's 12.
That was 12. 13, guess what it says? Take the cis form and write it in A plus BI form. So we're going backwards again. That's been the theme for the last several pairs of problems. Well, not several, 2 or 3. Here's something, do it in this form. Here's that form, now go back. That's what they're asking you to be able to convert from one to the other. So number 13 gives you something like this. 5 cosine of 5/6. This one is in, not degree form, it's in this form. Sine 5/6. This is what it looks like, something like that, and they want you to put it back in a plus bi form. What do we need to do that? How you want to start?
Plot
Plot it. What angle am I going to spin?
it.
5/6, where is it?
Second quadrant.
Second quadrant with a reference angle of pi/6, right? So this is 30 degrees. How long is it? 5. I need this point so that I have a real imaginary point to go to. That's what standard form is. So if this is 5, this is 5/2, isn't it? 30 degrees. And this is 5√3/2, but it's negative. So the rectangular point that they expect you to write is -5√3/2, comma 5/2. You want to put it in decimal form? Go ahead. If you can't remember your stuff well enough to be able to find those, then you have to do it yourself. It says, wait. Sorry, I lied. The instructions are written by the author of the test, and then in my handwriting after the size, it says answer in simple radical forms. This is the only answer.
So are we leaving like that, or are we supposed to put it in, like I form, like sort of the?
Oh, yeah.
that plus I?
You're absolutely right. This isn't correct. This is no good. That's better. Thank you. I would have missed a point on that one. Got the right thing, but we put it in the right form. Good catch. Sorry about that. Yep, A plus BI form, and it tells you that. And it even references that A plus BI form. But your answer must be in simplest radical form to get full credit. If you have the correct decimal form, I'll give you some, but not all. Means you're not having problems. You don't know your right triangles well enough to be able to do the simplest radical form. Okay, we ready? Number 14. Number 14 says, find the product of Z1 and Z2 given these types of things. So Z1. Z1 is something like this. I put the test on now. Okay. Something like this. 4 parentheses cosine -60 plus I sine -60. Oh, they have a bracket like this. And then Z2 is something like 18 cosine of 165 sine of 165. And they want you to find the product or the quotient as indicated, and it looks like I just gave it away. Number 14 is going to be a product. Shouldn't have said that, but it is. If it were a quotient, it wouldn't be that much more difficult, but this one's going to be a product. So we want to find Z1 times Z2. And that's going to be 4 times 18. 72 cosine of 105. Yeah. Now, do you leave it that way? Do you leave it that way? Leave your answer in trig form. It says that very clearly in the instructions. Leave your answer in trig form. So you may write it that way and put it in the blank, that's fine. You can also write it this way. Okay? It's pretty easy. And it's very tempting to just look at what's written on the test and just do the arithmetic in your head, which is fine if you're right. I would, if I were you, I would say Z1 times Z2 equals 4 times 18 times the cosine of 165 minus 60 plus I sine of 165 minus 60. But again, you guys don't want to do that because you're so sure of your arithmetic, and most of the time you're okay. If you're not showing me your work, it has to be something like this so that I can see what you intended, even if you didn't get it right. So, in a testing situation, you need to show something. Okay, that's number 14. Are we good?
Yeah.
Number 15 says, find the cube roots of something. I'll even tell you, it says cube roots. So you're going to be finding 3 roots of something. Let's say that we were going to find the 3 roots of 64. Find the cube roots of 64. You might look at that and say, no, there's only one cube root and it's 4. Yeah, there's only one real one. There are 3 complex ones. What should we do first?
Writing that A plus BI form.
Okay. Now what? You should graph it on a real imaginary grid. That's out 64. Right? What is the cis form of this now that you've graphed it?
64, 6.
That's the angle that I see when I plot that. Are we clear?
Yeah.
What's the first root? If it's written in cis form, what's the first of the 3 roots? Sorry, this shouldn't be 64, this should be 4. It's the cube root of 64. If you want to write it like this so that that you're showing the work that I just told you to give me, you can write it like that, and then the first one's going to be 4 cosine of 0 plus 0 times 2 pi over 4. 4? N, no, 3. N is this part. Well, that's still 0, right? But that's just it's just writing down all the things that it says. This is K. This is the original angle. We add that to 0 times 2 pi. This is the K value, the first K value divided by 3. That divided by 3 is 0. So what is the cosine of 0? 1. What is the sine of 0?
0.
0. 0i is just 0i, so this first root is 4. So we found the first one that you expected.
Where did the 3 come from?
Because in the formula for finding nth roots, this is n. And it's 3 because it's cubed. The cube roots.
Oh, so it'll always be 3 on this one.
On this one for this test, yes. If it had said find the 8th roots, this would be an 8. Okay? The second one is going to be 4 times the cosine of 0 plus 1 times 2 pi over 3, which is 2 pi thirds. You agree with that? Now, where's 2 pi thirds? I mean, if you're going to do things in radical form, I'm not sure you want to do it in radical form, but I do, because 2 pi thirds is familiar. 2 pi thirds is right here. And the cosine of 2 pi thirds is negative 1/2. Yeah. It's equal to 4 times negative 1/2 plus, what's the sign? Square root of 3/2, isn't it? So the next root is negative 2, because 4 times 1/2 is 2, plus, well, the 2 will cancel with the 4, so it's 2 root 3i. Okay, ready to move on? Third one is 4 times the cosine of 0 plus 2 pi times 2 divided by 3 plus I sine. And to reconcile that, that's going to be 4 pi thirds, which is equal to 4 times, so we come over here, 4 pi thirds is right here. And this angle is 4 pi thirds, yeah. But this point right here, this place I'm coming to, is going to be back 1/2 and down at negative root 3/2. So I have the cosine of that angle is negative 1/2. The sine of that angle is negative root 3/2, which means I'm going to get 4 times 1/2 is negative 2 minus the square root of 3, 2 square roots of 3, because the 4 cancels with the 2. These are the things that you will write in the blank. That comes before it is the work that you will show. If you want to verify it graphically, geometrically, like I just said, then you find the first one and you go 1/3 of the way around the circle. And you go another 1/3 of the way around the circle. And you find those coordinates, multiply them by 4. It's just what we did. That's in the second quadrant, this is in the third quadrant, multiply it by the cube root of 64. Those locations, radius of 4. Okay, that's how number 15 is going to be. Number 16 says, use the Moss theorem to evaluate and write your answer in standard A plus BI form. Everybody got this one down well enough? I can erase it, or do you want to take a picture, or you can use the video. Yeah, everybody good? Okay. All right, last one. The Moss theorem means now we're not going to root something, we are going to power a cis form equation. And so it might be something like this. 6 root 3 plus 6i to the 8th. Have to use the Moss theorem and put it in standard A plus BI form when we're done. It's the first thing we should do. Plot it. Good idea. So I'm going to go out 6 root 3 and up 6. Do you want me to do something in another quadrant besides the first, just to show you how things go?
Sure.
Yeah? Okay.
Yeah.
Then let me make this negative. So we're going to go out 6 root 3 and up 6 from the second quadrant, about right here. So that the triangle looks like this. This is negative 6 root 3. This is 6. Should indicate that you know the size of that angle. What is it?
30.
This one's 30, makes this 150, yeah? And the length of this is 12. So the cis form of this number is going to be 12 times the cosine of 150 plus I sine of 150. Okay, make sure you get the angle that goes there from the positive x-axis. So we have rewritten this in cis form, this part of it right here, and we want to 8th power it. I probably got a little carried away there. 12 to the 8th is enormous. We'll do it. 12 raised to the 8th. Whew. 1, 2, it's in the billions. So So the first thing you do is you take that exponent to the actual radius, which is 429981696. Now what? What will this be? The cosine of what? 8 times 150 plus I sine of 8 times 150. What's 8 times 150? 1200. Do we need to make that a degree measure between 0 and 360 before we proceed? No. Calculator doesn't care if it's 1200 degrees or something smaller. If you did do that though, the answer would be 120. 1200 degrees is the same thing as 120 degrees. They have the same terminal side. And the way I did it is I just kept subtracting 360 until I got something that was between 0 and 360. So if you wanted to do that, just to make sure that you're, looking at the answer yourself, you probably want to get this down. You don't have to do this step. However, 120 degrees is something that's familiar. 120 is 60 degrees, so 120 would be a stand-up triangle, actually, like this. Cosine of which is -1/2. Anyway, it doesn't matter. You can just start calculating if you want. So to put it in a plus bi form with this monstrously huge number that I never should have chosen, I would take that times this number here times the cosine of 120 or times the cosine of 1200. I don't care, and neither does your calculator. What's the cosine of 120? So I get, for the first one, this first thing, I get -214990848. Is that what you're getting? Did anybody do it with the 1200 and get the same thing? Plus, and now I'm going to take that same number, that monstrously huge thing. Got to go back up and get it. There it is. Times the sine of 120. And I get 372375071.9, but the 0.9 doesn't really matter at this point. I. Since this is a familiar angle, if you wanted to, you could also give me this in simplest radical form. Most people don't. I will tell you this. The number that's out here, the length of the vector, which is what that is, the r that's out here, and this power right here will give you something in the 4 to 5 digit range, but not 9. It's not going to be that huge. Okay? Everybody good? Okay, that's the test. Remember, if you want to have any chance at a bonus, you're going to have to look up the parametric equation section where they convert the parametric equation written in sine and cosine to zero. Okay, that's the review.